So, let's start. Number 11. Earth's position was not just lucky you are alive because Earth occupies one of the most precise locations possible. Earth's position is often explained using the term habitable zone, but that phrase makes it sound far more forgiving than it really is. Around every star, this zone is extremely narrow. Step outside it, and liquid water cannot exist for long. Planets either lose their water entirely or lock it away as permanent ice. Earth does neither. It sits almost perfectly in the middle, not near the edge, but settled in the safest range available. What makes this even more unusual is how stable Earth's orbit is. Many planets follow stretched or chaotic paths that cause dramatic temperature swings over time. Earth's orbit is nearly circular. That means the amount of sunlight it receives remains consistent year after year. This stability mattered deeply for early life. Chemical reactions are sensitive. If temperatures change too violently, those reactions fail, and life never has the chance to adapt. The sun completes this balance. It is not too large, not too small, and not overly violent. Some stars burn out too quickly, others release frequent radiation bursts that would constantly damage a planet's surface. Our sun provides steady energy over billions of years. When you combine Earth's distance, its stable orbit, and the sun's calm behavior, the result feels less like coincidence and more like a condition that had to remain stable long enough for intelligence to emerge. Number 10. Earth did not just have water, it had enough, and its stayed water is often described as essential for life. But that description does not fully capture how rare Earth's situation actually is. Earth does not simply contain water in small, temporary amounts, it has vast, deep oceans that have remained liquid for billions of years. Most rocky planets either lose their water early due to weak gravity or never maintain the right temperatures to keep it liquid for long. On Earth, timing was critical. After the planet cooled from its violent early formation, conditions stabilized quickly enough for oceans to form and persist. Once present, those oceans began acting as powerful climate regulators. Water absorbs heat slowly and releases it gradually, smoothing out temperature extremes across the planet. This created a calmer, more forgiving environment instead of one defined by constant instability. Water also makes complex chemistry possible. It dissolves minerals, transports nutrients, and allows molecules to interact without immediately breaking apart. Even ice behaves in an unusually helpful way, because ice floats. It forms an insulating layer that protects the water beneath and prevents oceans from freezing solid during cold periods. If ice sank instead, Earth's oceans would have frozen from the bottom upward, likely stopping life before it ever had time to develop. Earth's water did not just exist. It remained stable long enough to quietly support life's earliest steps. Number 9. Earth's atmosphere acts like a built-in life support system. Earth's atmosphere is often treated as background, but without it, the planet would be almost unrecognizable. It is not just a layer of gas surrounding the surface, it is a carefully balanced system that performs multiple critical functions at the same time. Nitrogen provides stability, oxygen supports complex organisms, and carbon dioxide helps regulate temperature. Shift these ratios even slightly, and life becomes far more difficult to sustain. The atmosphere also acts as a protective shield. Most meteoroids burn up before reaching the ground, and harmful ultraviolet radiation is filtered out before it can damage living tissue. Heat is distributed around the planet through winds and pressure systems, preventing extreme temperature differences between day and night. Oxygen itself presents a paradox. It is highly reactive and normally disappears by bonding with rocks. On Earth, it exists in large amounts only because living organisms constantly replenish it through photosynthesis. This creates a feedback loop where life maintains the atmosphere, and the atmosphere supports life in return. Clouds add another layer of control, reflecting excess sunlight while also trapping heat when needed. Taken together, the atmosphere behaves less like a random collection of gases and more like an active system that quietly adjusts to keep conditions stable. Without it, Earth would resemble Mars far more than the living world we know. Number 8. Earth's magnetic field quietly protects everything. Earth's magnetic field is invisible, but its absence would be devastating. This field deflects charged particles from the sun and blocks much of the dangerous radiation that constantly moves through space. Without that protection, Earth's atmosphere would be slowly stripped away, leaving the surface exposed and increasingly hostile. The magnetic field exists because of Earth's molten iron core, which behaves like a massive planetary dynamo. For this system to keep working, the planet must retain internal heat for billions of years, something many worlds fail to do. Some planets cool too quickly, others never generate a strong field at all. Earth managed to remain active long enough to shield its surface during life's most vulnerable stages. This protection also preserves genetic stability. Radiation damages DNA and increases mutation rates. While some mutation is necessary for evolution, too much pushes biological systems toward collapse. Earth's magnetic field keeps radiation levels low enough for slow, controlled evolutionary change instead of constant disruption. What makes this protection even more unusual is its consistency. The magnetic field has weakened and reversed at times, but it never vanished for long. That long-term shielding allowed life to gradually move from oceans to land and continue growing in complexity. Without this invisible barrier, Earth's surface would likely be sterile today, shaped by radiation instead of biology. Number 7. Earth's gravity falls into a narrow, functional range. Gravity seems simple, but nearly every system that supports life depends on it being precisely balanced. Earth's gravity is strong enough to hold onto a thick atmosphere in vast oceans, yet not so strong that it crushes complex organisms or turns the planet into something unrecognizable. This balance is unusually narrow, and Earth sits squarely within it. If the planet were significantly smaller, its weaker gravity would allow solar radiation to slowly strip away the atmosphere. Just as it did on Mars, without sufficient air pressure, liquid water would evaporate or freeze, making surface life difficult to sustain. If Earth were much larger, gravity would be stronger, and the atmosphere would become thicker and heavier. Breathing would be harder. Body heat would be more difficult to regulate, and complex life would struggle to function. Gravity also shapes biology itself. Muscles, bones, and circulatory systems evolved specifically to operate under Earth's gravitational pull. Blood flows efficiently without extreme pressure, and bodies can grow large without collapsing under their own weight. Even simple movement depends on gravity staying within a narrow range. Rain falls gently enough to nourish ecosystems rather than destroy them. Oceans remain deep but survivable near the surface, and the sky stays where it belongs instead of slowly leaking into space. Number 6. Plate tectonics keep the planet from breaking permanently. Earth is not a static world. Its surface is constantly shifting, breaking apart, colliding, and reshaping itself through plate tectonics. While this movement often appears destructive, it plays a central role in keeping the planet habitable over long periods of time. Without it, Earth would likely drift toward extremes, either freezing over or overheating beyond recovery. Plate tectonics function as a planetary recycling system. Carbon dioxide is released into the atmosphere through volcanic activity, then slowly removed as it becomes locked into rocks and sediments. Over geological time, this process helps regulate global temperature. When the planet cools too much, volcanic activity adds warming gases. When it heats up, those gases are gradually pulled back out of the atmosphere. Tectonic movement also brings essential elements to the surface. Nutrients such as phosphorus and iron are continuously recycled from deep within the planet and redistributed across continents and oceans. Life depends on these materials, and without this constant renewal, ecosystems would eventually exhaust their resources. The movement of plates also creates environmental diversity. Mountains, valleys, coastlines, islands, and deep ocean trenches exist because the crust is alive. This variety produces countless habitats, allowing life to adapt, specialize, and follow multiple evolutionary paths instead of being confined to a single fragile environment. Number 5. The moon quietly stabilizes Earth's long-term behavior. Earth's moon plays a far greater role than its appearance suggests. It is unusually large relative to the planet it orbits, and that size gives it an important stabilizing influence. The moon helps keep Earth's axial tilt steady over long periods of time, which allows seasons to remain relatively predictable. Without this stabilization, Earth's tilt would vary chaotically. Polar regions could suddenly experience extreme heat, while equatorial regions might plunge into cold. Such dramatic shifts would constantly disrupt ecosystems and make long-term evolution far more difficult. The moon also governs tides, which do more than move water back and forth along coastlines. Tidal forces mix nutrients throughout the oceans, supporting marine ecosystems and increasing biological productivity. They also create dynamic coastal environments where early life may have transitioned from water to land. These constantly changing zones encourage adaptation and experimentation. The moon's origin adds another layer of coincidence. The leading theory suggests it formed from a massive collision early in Earth's history. Somehow, that impact did not destroy the planet. Instead, it produced a moon at just the right distance. Too close, and tides would be destructive. Too far, and they would be ineffective. Acting as a silent partner, the moon helps keep Earth stable and biologically active in ways that rarely draw attention. Number 4. Earth's chemistry is unusually friendly to complexity. The chemical environment of Earth does more than allow life to exist. It actively encourages complexity to form and persist. The elements most important for biology are abundant and easily accessible. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur are all present in forms that readily combine to build complex molecules. Carbon is especially important because of its ability to form strong yet flexible bonds. This allows for an enormous range of stable structures, from simple molecules to the intricate systems found in living cells. While other elements might theoretically support life, none match carbon's versatility under Earth-like conditions. Temperature also plays a critical role. Earth's surface remains within a range where molecules can form without instantly breaking apart or freezing solid. This stability allows chemical systems to grow more complex over time instead of being repeatedly reset. Water strengthens this process by acting as a solvent, bringing molecules together and allowing reactions to occur smoothly. energy is available in many forms: sunlight, geothermal heat, chemical gradients, and electrical activity all provide ways for life to power itself. This diversity makes biological systems more resilient. Taken together, Earth's chemistry feels less like a random mix of ingredients and more like an environment that quietly welcomes complexity, even though such conditions appear to be anything but common. Number 3, Earth had time, calm, and room for second chances. One of the most overlooked reasons Earth supports complex life is not just where it is, but how long it remains stable. Life does not appear instantly. It requires immense spans of time to move from simple chemistry to complex organisms. Earth managed to stay habitable for billions of years without permanently breaking its life support systems. Early in its history, the planet experienced violent conditions. Asteroid impacts were frequent, volcanic eruptions reshaped the surface, and the atmosphere changed dramatically. Yet after that chaotic phase, Earth settled into a long period of relative calm. This calm did not mean safety. Mass extinctions still occurred, but they were spaced far enough apart for life to recover and grow more complex afterward. That balance mattered. Too much chaos in life never progresses beyond simple forms. Too much stability in evolution slows. Earth somehow stayed between those extremes. Just as important, the planet avoided irreversible failures. The oceans never boiled away permanently. The atmosphere never collapsed completely. The magnetic field never vanished for long. Each time Earth was pushed toward the edge, it pulled back before crossing a point of no return. Time is one of the rarest ingredients for life. Earth did not just have it, it managed to protect it. Number 2, when everything is combined. Earth stops feeling accidental when each life-supporting factor is considered on its own. It is easy to dismiss it as luck, a good location, enough water, a stable atmosphere, but when all of these elements are stacked together, that explanation becomes harder to accept. Earth's position, its oceans, its atmosphere, its magnetic field, its gravity, its tectonic activity, its moon, its chemistry, and its long-term stability do not operate in isolation. They function like parts of a single, interconnected system. Water helps regulate climate. The atmosphere protects that water. The magnetic field protects the atmosphere. Plate tectonics stabilize temperature over geological time. The moon stabilizes Earth's tilt. Remove any one of these components and the entire structure weakens, or collapses entirely. This does not automatically mean Earth was designed, but it strongly suggests that truly life-friendly planets may be far rarer than once assumed. The universe may be filled with planets, yet very few capable of maintaining this level of balance for billions of years. As astronomers discover more exoplanets, many are found to be close, but never quite close enough. Too hot, too cold, too unstable, or too chaotic. Earth continues to stand out, not because it is perfect, but because it is consistently good in every category that matters. The unsettling possibility is that Earth is not one of many. It may be an exception. And if that is true, then life like ours is far more fragile, and far more valuable, than we usually allow ourselves to believe. Number 1. Earth avoided the failures that end most worlds. What makes Earth truly unusual is not that it formed with favorable conditions, but that it repeatedly avoided permanent collapse. Many planets likely begin with some of the ingredients needed for life. What they lack is resilience. Earth was pushed toward failure many times, yet it never crossed an irreversible threshold. The planet experienced periods when oceans could have boiled away, when the atmosphere could have thinned beyond recovery, when internal heat could have faded and shut down protective systems. Each time, Earth came close enough to reveal the risk, but not close enough to end the process entirely. This pattern matters. Habitability is not a single event. It is a continuous test. A planet must survive not just one crisis, but millions of years of compounding threats. Most worlds fail quietly, without drama, simply drifting past points of no return. Earth did not. Its systems bent instead of breaking. That ability to recover is rare, and it may be the difference between planets that briefly flirt with life and those that carry it long enough for intelligence to emerge. When viewed this way, Earth's greatest feature is not perfection, but endurance. And endurance is something the universe does not seem eager to provide. If ideas like this stay with you longer than they should, you might want to stay a little closer. These stories aren't meant to give answers, only better questions. If you'd like to keep exploring them, consider liking the video and subscribing to the channel. More unsettling truths are already waiting, quietly, just beyond what feels comfortable.